In this video, we're going to find the eigenvalues and the eigenvectors for this 3x3 matrix. After writing out the identity matrix, you can multiply lambda onto each of the individual components, which then gets you to this matrix. A just refers to the matrix that's given to you in the question, and when you subtract lambda I from it, all you're doing is minus 2 take away lambda. Here, we're not really subtracting anything from it because this is 0, but the middle term becomes 1 minus lambda, just like I've written out here, and 5 minus lambda is just the last term there. To find the determinant of a 3x3 matrix, we take this value and multiply onto it the matrix here, and the determinant of it. And then we take away minus 4, which is plus 4 lots of minus 2, 2, 4, 5 minus lambda. And then we add 2 lots of minus 2, 2, 1 minus lambda 4, just like I've written out here. A bit of a long question, but from there you sort of expand and simplify and collect all the like terms. So I've simplified this quite a bit by collecting like terms. Otherwise we're just going to keep going and going, and then, yeah, this paper only goes up to here. Once again, you expand out all the brackets just like I've done here. And then you're going to collect like terms, which I'm just going to do here. And then like I mentioned here, we're going to make that determinant now equal to 0 to then solve for lambda. Solving for lambda will give you the eigenvalues that you're looking for. Once you've collected like terms, I would recommend multiplying by minus 1 and then going on to solve this equation using the factor theorem. I'm not going to go through the factor theorem, I'm sure you guys know how to do it, but these will be the 3 eigenvalues that you end up at. And now we're going to substitute each of these eigenvalues into the expression a minus lambda I that we formed previously. And our goal from there is to find a set of values x and y, so that when you multiply this onto x and y, it will give you that 0 matrix. After putting it into this expression, what we can see is that 3 times x plus minus 4 times y plus 2 times z is all equal to that first vector there, 0. You can form 3 more expressions just like I've done here, and then you want to solve these simultaneous equations to get values of x, y and z. If you'd like me to make a separate video about how to solve simultaneous equations where x, y and z are included, just let me know and I'll make that. When you do solve these expressions, you'll get that x is 2 times bigger than y and z is minus y. That's useful in forming the eigenvector, which by the way is in the form x, y, z, because you can say that if y is something like 1, then z would be minus 1, and x would be 2 times that y value, so just 2. And all other eigenvectors are multiples of this. For example, 4, 2, and minus 2. If you multiply it all by 3, you get 6, 3, and minus 3. So this is your final answer. This is the eigenvector for this specific eigenvalue. And then you do the same exact process to find the eigenvectors for each of these eigenvalues. Very long question, and yeah, if they give this in an exam, they'd only ask you to find it for one specific eigenvalue. They wouldn't expect you to do the whole process again and again for 3 different eigenvalues. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.